Hello everyone, my name is Teresa Samantha, and in this video I will explain how to conduct statistical analysis using SMARTPLS with the impact of financial attitude and literacy on investment decisions with home bias as a mediation variable as a case study. So I will take you step by step from importing the Excel data, building the model, making the hypothesis, explaining the steps to conduct all the tests, and interpreting all the results. So without further ado, let's get started. So first, you want to open the Excel file where the data you want to use is. In my case, I'm opening the data from the Google Forms survey, which has 160 samples. And now I'm going to delete the ones I won't use. So I will only be using the indicators for home bias, financial literacy, financial attitude, and investment decision. After that, just rename the indicators to make it easier, like HP1, HP2, HP3, and HP4. The same goes for the other indicators. Now you're going to click File, then Export, and then click on Download the sheet as CSV. As you can see, the file is downloaded. Now open your SMARTPLS application, click on New Project, and name it according to your heart's desires. I'm going to name mine ALP Stats. Click OK, and then double-click to import data. Choose the CSV file you've downloaded and open it. You can choose to rename it if you want, but I'm not going to. Then click OK. Here you can see the descriptive statistics. To draw the research model, double-click the ALP Stats button to go to the drawing pad. After that, you want to select HP1 to HP4 and then drag it to the drawing pad. Do this for all the variables. Then just arrange the variables according to their position. So here I have two independent variables, financial attitude and financial literacy. Then in the middle is the mediation variable, which is home bias. After that is my dependent variable, which is investment decision. Then right-click the variable and rename it accordingly. So this one is financial attitude. Click OK, do so for all the variables. Afterwards, you're going to click on Connect and then click on Financial Attitude and drag the arrow to Home Bias to Investment Decision, and so on. Make sure that all variables are connected and pay attention to not confuse where the arrowheads are pointing at. So now I have 7 hypotheses. First one is financial attitude has a significant effect on investment decision. 2. Financial literacy has a significant effect on investment decision. 3. Financial attitude has a significant effect on home bias. 4. Financial literacy has a significant effect on home bias. 5. Home bias has a significant effect on investment decision. 6. Home bias mediates the relationship between financial attitude and investment decision. 7. Home bias mediates the relationship between financial literacy and investment decision. After that, you're going to click on Calculate and then press PLS algorithm. You're not going to change the default setting here. It should be path 307. Then click Start Calculation. Okay, so first we're going to interpret the outer model. First step is factor loading. Now you're going to click on outer loadings. So as you can see, some variables are red. That means it's below 0.7. So you're going to have to delete those red indicators in the drawing pad. But make sure that each variable has a minimum of 3 green indicators. After that, you're going to click on Calculate again and then press PLS algorithm. Click outer loadings again and see if all indicators are 0.7 or above, or see whether it's green or red. If it's all green, then all the indicators are suitable for use in this research and can proceed to the next test. The next step is to check on its internal consistency, reliability, and convergent validity. You're going to click on Construct Reliability and Validity. So there are 3 indexes: Composite Reliability, Cronbach's Alpha, and Row A. For Composite Reliability and Cronbach's Alpha, they have to be 0.7 or above, but maximum at 0.95 to avoid indicator redundancy. For Row A, it has to be 0.7 or above, and it should be between Cronbach's Alpha and Composite Reliability. Next, the average variance extracted, or the AVE, has to be 0.5 or above. If that's all true, it should be all green, and we can move on. Next up is discriminant validity, so just click on that. For this analysis, you can choose to use the Fornell-Larker criterion, cross-loading, or hetero-tray-monotray ratio, or HTMT. The HTMT is recommended since it is the most easy to detect when there are data that don't fit the criteria. So in this video, I'm going to use that, and it has to be 0.9 or below. Otherwise, it is not valid. So all the data on the screen are valid. As you can see, it is all green and below 0.9. The next step is the collinearity analysis. For this one, you're going to click on Collinearity Statistics, VIF. Then from the outer VIF values, check if that data is 5 or below. So this is all below 5, so it's safe. Since the outer model is finished, we're going to check the inner model, which is the relationship between the variables. Now click on inner VIF values and check if all is below 5. So yep, it is. So there is no multicollinearity happening. Next, we're going to check the partial significance. For that, we're going to go back to the drawing pad, click on calculate and choose bootstrapping. Don't change anything here. Use 500 subsamples to reduce processing time, basic bootstrapping, bias corrected and accelerated bootstrap, two-tailed, and 0.05 significance level. Click Start Calculation. Now from the path coefficients, we can check direct effects from the p-values column. So the p-value has to be below 0.05 for it to be significant. So FA to HB is significant, FA to ID is significant, FL to HB is not significant, FL to ID is significant, and HB to ID is not significant. After that, check for the indirect effects. So click on specific indirect effects. Here you can see that the p-values are all above 0.05. So that means there are no indirect effects, which equates to no mediation happening. Next, let's check the coefficient of determination. For this, you're going to go back to the PLS algorithm and click on R-square over here. So commonly, R-square that is more than 50% for primary data is good, but there is no universal standard, just that the higher, the better it is. So as you can see for home bias, it is 10.6% for its R-square value, whereas it's 42.5% for investment decision. This indicates that 42.5% of investment decision can be explained using 3 variables, namely financial attitude, financial literacy, and home bias, while the other 57.5% might be explained by other variables that are not included in this research. Next is the effect size. Now you're going to click on F-square. So F-square is the difference in R-square that occurs when an independent variable is removed from the model. So as you can see, the F-square effect size of financial attitude with home bias is considered small since the value exceeded 0.02, but is still below 0.15. The F-square effect size is also small for financial attitude with investment decision. For financial literacy with home bias, it has no effect since it is below 0.02 because that's 0.002. While financial literacy with investment decision has a large effect since it's above 0.35. Lastly, home bias with investment decision has no effect since it is below 0.02. Okay, next up we're going to check the Q-square. To do this, you're going to go back to the drawing pad page again, then click on calculate and then blindfolding. Again, don't do anything to this page. Now click on start calculation. So we're doing the test to assess the predictive accuracy of this PLS model. Now look at the Q-square column. So for this, the home bias variable regression model has a small PR, while the investment decision model has a medium PR. These independent variables are set to be accurate and valid to predict the Y variable, since the Q-square values have all exceeded 0, which is the minimum required value. So in conclusion, financial attitude has a positive significant effect on investment decision, financial literacy has a positive significant effect on investment decision, financial attitude has a positive significant effect on home bias, financial literacy does not affect home bias does not affect investment decision, home bias does not mediate the relationship between financial attitude and investment decision. It means there is no mediation because there is no indirect effect since home bias to investment decision is not significant. Lastly, home bias does not mediate the relationship between financial literacy and investment decision. It means there is no mediation because there is no indirect effect since financial literacy to home bias is not significant and home bias to investment decision is not significant as well. So that concludes the material, and I hope that this video has been useful. Thank you for watching. See you in the next video.